In this video, we're going to look at modeling using variation. We're going to solve direct variation problems, solve inverse variation problems, and solve problems involving joint variation. So with your partner or on your own, answer the following questions. In your own words, explain why it's important to check solutions for radical equations. Well, based on my previous videos, what ends up happening with radical equations is that you can end up with an extraneous solution. A solution algebraically you can get, but when you go back to check it, it actually doesn't work. And the same thing with rational equations, is that algebraically you can come up with a solution, but that solution could be extraneous. And the last one here, the average cost of producing X electrical pencil sharpeners is given by the function 20 plus 4,000 divided by X. Find the number of electric pencil sharpeners that must be produced to find the average cost of 25. So in this case, since we have the average cost of what we're seeking, that is my f of x, so I'm chasing the x. So 25 is equal to 20 plus 4,000 divided by x. I'm going to subtract 20 from both sides, and I'm going to get 5 is equal to 4,000 divided by x. I'm going to multiply both sides by the LCD, which is x over 1. And I end up with 5x is equal to 4,000, divide both sides by 5, and I get 800. So I need to make 800 pencil sharpeners to have an average cost of $25. And the reason I knew that is because X is the cost, the average cost of producing, well actually X is the number of pencil sharpeners, and f of x is the cost. Since I want the cost to be 25, I set the function equal to 25 and I solved. First, we're going to look at direct variation. So when we are reading application problems, we're going to see words like varies directly. So y is equal to k, which is the variation, the constant of variation, and then multiplied by x, or x to the n. So if I want to find k, then I would have k is equal to y divided by x to the n. The constant of variation cannot be 0, because if it was 0, then you'd say y is equal to 0. When I'm asked to find the problem where I have direct variation, the first thing I'm going to be given is enough information to find that constant of variation. So I'm going to identify what x and y is, where x is the input, y is the output. And then I'm going to solve for the constant of variation. And then the next step after I found that is use the next bit of information to determine what it is that I'm searching for, and then solve for that variable that is unknown. So the key words I'm going to look for is y varies directly as x. When x is equal to 6, y is 12. So I can find the constant of variation. So I have y is equal to kx, because I have varies directly. So 12 is equal to k multiplied by 6, so my constant of variation has to be 2. Once I have that, then if I have another set of information, either x or y, I can solve for the missing variable. Y varies directly as the square root of x. So again, I'm going to have y varies directly as the square root of x. So I'm going to have 24 is equal to k multiplied the square root of 36. Square root of 36 is 6, so I'm going to have 24 is equal to 6 multiplied by k. Solving for k, I'm going to get k is equal to 4. Now, I didn't do it on the previous one, but I should do it, and I will do it on this one as well. So now my equation is y is equal to 4x. Just like my equation here, y is equal to 2x. Oh, and that should be the square root of x on the second one. The square root of x. Y varies directly as a fourth power of x when x is 1, y is 6. So y varies directly as kx to the fourth. So when x is 1, y is 6, so 6 is equal to k multiplied by 1 to the fourth, so k is equal to 6. So my equation is y is equal to 6x to the fourth. All right, not too bad. Inversely, we'll be looking for the keywords as varies inversely, inversely proportional to, or inverse variations. And what we're going to see is y is equal to k, and then x is going to be in the denominator. So when I solve for k is going to be x to the n multiplied by y. Once again, I'm going to identify the input-output. I'm going to determine the constant of variation. I'm going to use the constant of variation to rewrite the equation and then find the missing pieces. So if we take a look at part A here, I'm going to be looking for the keywords varies inversely. So I'm going to have y is equal to k divided by x. So when y is 2, k is 4. I should say when x is 4, y is 2. Solving for k is equal to 8. So the equation that I'm looking for is y is equal to 8 over x. Varies inversely as the fourth power of x. So I'm going to have y is equal to k divided by x to the fourth. So when x is 3, y is 1. So 1 is equal to k over 3 to the fourth power. So k happens to be 81. That's 3 to the fourth power. And so y is equal to 81 over x to the fourth. And lastly here, y varies inversely as the cube root of x. So y is equal to k over the cube root of x. When x is 64, y is 5. So 5 is equal to k divided by the cube root of 64. The cube root of 64 is 4, so I have 20 is equal to k. So my equation is y is equal to 20 divided by the cube root of x. And then, of course, we have jointly varies. So it could be varies directly as x and inversely as z. Or it could be we have directly as y varies directly as x and the square root of z. So we're going to have more than one possible one. But as before, we still need to set it up, find the k, and then use that information to find whatever variables that are missing. Y varies jointly with x and z. So y varies jointly as k. X doesn't have any power and z doesn't have power, so we're assuming that they're 1. So when x is 2 and z is 3, it's going to be multiplied by k. This will equal 36. So k will end up becoming 6. So my equation is y is equal to 6xz. Y varies jointly as x and the square root of z. So y is equal to k, x, and the square root of z. So when x is 2 and z is 25, so the square root of 25 multiplied by k is equal to y. So 10k is equal to y, so k is equal to 1/10. So my equation is y is equal to 1/10, x, and then the square root of z. Now, for question number 1, the quotient of a number and 9 times its reciprocal is 1. So 9 times its reciprocal, so 9 multiplied by 1 over my variable, I'll use x. X equals the number. And then let me see. The quotient of a number, so I'm going to take x and I'm going to divide it by this, and it's going to equal 1. So what I have is x over 9 over x is equal to 1. So I'm going to multiply both sides by 9 over x. So I'm going to get x is equal to 9 over x. So then x squared is equal to 9. So then x is equal to plus and minus 3. On this one, I actually didn't have to do the setup as varies jointly or varies inversely. Now on part 2, I am going to actually do this as an inverse, because the more people working on it, the less time I would expect to happen. So with Destin can word process a research paper in 6 hours. With Frank's help, the paper can be processed in 4 hours. How long does it take Frank to process the paper alone? So for this, I know it's gonna take Destin to write one paper. It's gonna take him 6 hours, or them 6 hours. Frank's help. Frank alone could do it one paper in F hours, but combined they can take and write one paper in 4 hours. So my LCD here is going to be 12, because that's the lowest common multiple of 4 and 6, 12F. So I'm going to multiply every term by 12F over 1. And I'm going to end up with 2F plus 12 is equal to 3F. So 12 is equal to F. So it would take Frank 12 hours to write or process the research paper on his own. So not slow, but not fast. So that's number 2. On question number 3, I'm going to write this as rate times time equals distance. So rate multiplied by time is equal to distance. The speed of Katie's boat in still water is 24 miles per hour. If she drives the boat upstream, so she's fighting the current. If she drives the boat 54 miles upstream, in the same time it takes her to travel 90 miles downstream on the Colorado River, find the speed of the river's current. So I'm going to do upstream. I'm going to do downstream. I have the rate times time is equal to distance. So the rate upstream would be the rate of the boat, which is 24, and then minus the current. I'm going to call that C. Let C equal the current. Then going downstream, they will have the rate of the boat plus the current will help them along. If she drives the boat, that should be drives, not dives the boat, drives the boat 54 miles upstream, so 54 miles upstream, and 90 miles downstream, and the time is the same. So this produces 24 minus C multiplied by the time is equal to 54. And this one produces 24 plus C multiplied by the time, and it's 90. So 2 equations, 2 unknowns. Let's solve for t. So I'm going to take this and solve for t, and I'm going to have 54 divided by 24 minus c is equal to t. I'm going to do the same thing here, and so I'm going to have 90, 24 plus c is equal to t. Since the times are the same, I'm going to set them equal to each other, so 54 over 24 minus c is equal to 90 over 24 plus c. Now my lowest common denominator should say, is 24 minus c, 24 plus c. So I'm going to multiply both sides by my lowest common denominator. So I'm going to end up with 54 multiplied by 24 plus c. And on the other side, I'm going to have 90 multiplied by 24 minus c. I'm going to get my calculator out. And 54 times 24 is 1296 plus 54c. And on the other side, 90 times 24 is 2160 minus 90c. I'm going to bring the c's to the left. Yeah, I'll bring the c's to the left and the 1296 to the right. And on the left-hand side, I'm going to get 144c. On the right-hand side, I'm going to get 864. So the current is 6 miles per hour. So not a bad current. If we take a look at the electronics, the number 4, in electronics relationship among resistance, R1 and R2 in ohms, of 2 resistors wired in parallel circuit, and their combined resistance R can be described by this formula. Find the combined resistance of 2 resistors of 12 ohms each when they are wired in a parallel circuit. This one's actually really nice because it's already set up for us. 1 over R is equal to 1 over 12 plus 1 over 12. 12R is my LCD. Multiply by everything by 12R. I'm going to get 12 is equal to R plus R, which is 2R. So R is equal to 6. That was nice. If a number is subtracted from the numerator of 13/8 and added to the denominator of 13/8, the resulting fraction is equivalent to 2/5. All right, so x is equal to the number. I have 13 minus x over 8 plus x, and when I get done, I get 2/5. My LCD is going to be 5 multiplied by 8 minus x. It's going to be plus x. So I'm going to end up with 13 minus x, which is going to be multiplied by 5. On the other side, I'm going to get 2 multiplied by 8 plus x. So 13 multiplied by 5 is 65 minus 5x. On the other side, I'm going to get 16 plus 2x. I'm going to add 5x to both sides and subtract off 16. So I'm going to have 7x. And on the left-hand side, I'm going to get 49. So x is equal to 7. This would be a quick check. Number 6. Jake and Greg and Jared can sort a stack of mail in 20 minutes, 30 minutes, and 60 minutes respectively. How long does it take them to sort the mail together? Starting with Greg. 1 over the 20 minutes, 1 sorting takes him 20 minutes. Plus 1 sorting for Jake takes 30 minutes. Plus 1 sorting takes Jared 30 or 60 minutes. And we want to know the combined, so we have 1 over x, where x is the combined time. So my LCD happens to be 60x. Multiplying everything by 60x. I'm going to get 3x plus 2x plus x is equal to 60. So 6x is equal to 60. So working together is only going to take them 10 minutes. That's not too bad. So Courtney is flying an F-100 plane, and Mackenzie is in her Toyota truck, leaves the same Denver at sunrise and heads to Santa Fe, which is 450 miles away. Direct, not following the road. The speed of the plane is 3 times the speed of the truck. The plane arrives after 6 hours, or arrives 6 hours ahead of the truck. Find the speed of the truck. Okay, so I'm going to have the truck. I'm going to have the plane. We know rate times time is equal to distance all day long. So the distance is 450, so this is 450, and this is also 450. The plane arrives 6 hours ahead of the truck, so the time for the plane is t, and t plus 6 is the time it takes for the truck to get there. The plane is 3 times the speed of the truck, so R is the truck, and 3R would be the rate of the plane. So what I have is I have R multiplied by T plus 6 is 450. Simultaneously, I have 3R multiplied by T is 450. Let me see. I want to eliminate one of the variables, so I'm not going to set them equal to each other. So let's solve for R. So R, what are we asking for? Is find the speed of the truck. Okay, yeah, so solve for T instead of R, because that way I'll have everything in terms of R. So T is equal to 450 divided by 3R. So T, let's reduce this. 450 divided by 3 is 150. So 150 divided by R. I'm going to put that into this one. So I have R multiplied by 150 divided by R plus 6 is equal to 450. Distributing the R, I get 150 plus 6R is equal to 450. So 6R is equal to 300. So R is equal to 50 miles per hour. And it is highly likely they're probably in front of me the whole way. Makes me want to cry. Anyways, that's it for this video. Nice short one. We'll see you in class.